You may have seen several ways to represent covalent bonds like this, or this, or this, or this, or even this. In fact, there are many ways to draw a covalent bond. Covalent bonds suggest an overlap of orbitals to share electrons. Using dot and cross diagrams, we can show that one of the shared electrons comes from each atom. This example shows the bonding in a chlorine molecule. Notice that only the valence electrons have been shown. If we label the nucleus as Cl, we don't need to draw out all the rest. Chlorine can't steal an electron from another chlorine because they are both pulling on the electrons just as hard. Let's look at another example. This one is a bit trickier. Two oxygen atoms bond covalently. Oxygen has just 6 electrons in its outer shell. Can you remember what kind of bonds they form? Pause the video while you work out the dot and cross diagram. Okay, let's see the answer. Oxygen forms a double bond, so 2 dots and 2 crosses must be squashed into the overlap or touching area. Pairs of electrons may not be drawn evenly distributed over 4 sides anymore, but this doesn't matter as long as there are still the right number of dots and crosses around the atoms and in the bond. Did you notice that one oxygen had crosses and the other dots, even though they are the same element? Dots and crosses don't distinguish between different kinds of atoms, just that they are neighbors. It doesn't matter which atom has the dots and which atom has the crosses, as long as bonds form between one atom with each. In calcium chloride, we can't tell which electron went to which chlorine, but we can tell that calcium has lost 2 electrons and chlorine atoms have taken them up. If the first chloride ion is drawn with crosses, and next we draw our calcium ion with dots, we have to draw our next chloride ion with crosses too. Otherwise, we would have 2 dots next to each other, and we wouldn't be able to tell where the electrons came from. Let's practice working out the dots and crosses using a linear or chain molecule. Hydrogen peroxide. Hydrogen peroxide bonds like this, HOOH. How would you draw the dots and cross diagram for hydrogen peroxide? Pause the video again. Have you got it? There are 2 ways you could draw the dot and cross diagram of hydrogen peroxide. The first hydrogen would be dots, the first oxygen crosses, the next oxygen dots, and the final hydrogen crosses, or the other way around. This is the same as turning the molecule around. So there is really only one way to draw the dots and crosses diagram. Remember, hydrogen peroxide is a small covalent molecule, so it shares electrons. I hope you've enjoyed this video on dots and crosses diagrams, and now feel confident representing ionic and covalent bonds using dots and crosses.